Greetings of the day. Welcome to the course on Operations Research Technique. Students, we have finished 2 units and right now we are in 3rd unit called Dynamic Programming. In Dynamic Programming, we have also discussed in earlier lectures that how this dynamic programming differs from the concept linear programming, which we have studied under Unit 1. As the name implies, in dynamic programming, at every stage of the problem, when the problem is divided into number of stages, at each stage of the problem, whatsoever is the result of previous stage, we are optimizing the solution at current stage and we are moving ahead. We have seen that how recursion relations are used in the concept of dynamic programming and how we call back function from the already obtained answer in previous stage. For that, we have seen the example of Fibonacci series, wherein we have said that we got the sum of previous two numbers and addition of previous two numbers gives sequentially the next number as in Fibonacci series. Now we also solved the problems where the decision variables were greater than equal to 0 and where integers meaning it is either complete number like 1, 2, 3, 4 like that. If I am saying that it is not discrete, it is continuous, means decision variable will obtain the value ranging between these two numbers, end numbers, suppose 1 to 2, 1.5, 1.7, 2 to 3, 2.9, 2.7 like that. So whenever in problem, suppose it is given that the decision variables are only integers greater than equal to 0 and integers, we have to use the tabular method which we have already discussed. And if it is given that only numbers are greater than equal to 0, then definitely the variables are continuous variables and we have to apply calculus method. So both aspect we will study in today's lecture. So let's move with one more problem for tabular method. Now here as you can see that the firm is supposed to take some decision pertaining to the area of marketing and for that, as a strategy of the company, they have divided their marketing in 3 different zones labeled as zone 1, zone 2, zone 3, and they have number of salesmen available with them. The task is how to allocate this number of salesmen to different zones, given number of salesmen to different zones, zone 1, zone 2, zone 3, so as to maximize the objective function. What is that we will see here? The amount of sales, so obviously they have to maximize their sales. If the sales is maximized naturally, the firm will enjoy more profit. The amount of sales depends upon number of salesmen in each zone. How much number of salesmen they allocate in each zone, that will be reflecting your sales quantity. Now from previous data, the firm has been collecting the data regarding sales and salesmen in each area for past years. So based on their earlier sales record, they have some data available. The profit in thousand of rupees, now whatever values given in this particular table are in thousand of rupees. So number of salesmen ranging from 0 to 9 means total number of salesmen are available 9, and 9 salesmen are to be distributed in zone 1, zone 2, zone 3 simultaneously so that sales is maximized. That is the objective function. And these values, suppose you read it 30, suppose you read it 45, this is 30 means 30 in thousand, so this will be 30 thousands. So profit by deputing these number of salesmen in respective zone is given in the table in thousands of rupees. Next, Here only 9 salesmen are available. So this condition is given. Number of salesmen available are 9. Constraints are given, specified in the form of number of salesmen available. And problem is to allocate these salesmen to 3 different zones so that total sales is maximized. So as I have discussed right now, maximize sales is objective function. You have constraint on the number of salesmen. So total number of salesmen available, maximum 9. So depending on situation, you can have this combination from 0 to 9. With these constraints of total number of salesmen available, and distribute these number of salesmen in zone 1, zone 2, zone 3 as a marketing strategy, we have to maximize sale. That is the objective function. Students, now in this problem, we cannot take these number of salesmen as continuous variable. We cannot depute 4.5 salesmen. We cannot depute 2.5 salesmen. Either we will depute no salesman, means 0 salesman, or we will depute salesmen ranging from 1 to 9. That's all. No in between figure, no continuous value ranging from 0 to 9 is possible. And therefore, this problem is in the category of discrete numbers. And you know, when values are in the form of discrete nature, we are using tabular concept. So here I cannot go for calculus method, we have to go for tabular method. So now we know the problem will be in 3 stages. It will be in 3 stages. Target is maximize sale. So you can have only one combination of zone 1, that is one possibility. Similarly, other combination is zone 1 and zone 2 stage, then optimal of zone 1 and zone 2 with zone 3 third stage. And in this case, in this process, we will move from initial position stepwise, stage-wise to all 3 zones, and we will use the principle of dynamic programming stated by Bell-Coleman, which is called like Bell-Coleman's principle of optimality, which we have discussed in very first lecture. So let's move. Now the theme of problem is very clear. These values, profit values for different zones are utmost important to us for making decisions. Got it? So we will move step by step ahead and we will find this number of salesmen, number of salesmen to salesmen to be allocated to each zone. That we'll see. Clear? So let's move ahead. Now focus your attention on these values. For these number of salesmen, these are the profits. If you depute these number of salesmen to either zone 1, zone 2 or zone 3. Let's move ahead. Now, how the solution runs? This is very essential to understand the basic concept. Let three zones represent the three stages as we did in previous problem, and number of salesmen represent the state variable. So we have seen in earlier case, what do you mean by stage and what is state and what are state variables. So naturally, as I have explained in previous slide, we will, for this problem, we will be having three stages representing zone 1, 2 and 3. And the variables, that is number of salesmen, in each zone combination will be giving us states. Now problem, as I have said, it will be in three stages: stage 1, stage 2 and stage 3. So it will be for zone 1, then zone 1 plus 2, optimum of 1 plus 2 and 3. So in stage 3, what we will be finding is current decision, and here we will be getting optimal values from combined of zone 1 and zone 2. Let's see. Now if we consider only stage 1, in that the amount of cells corresponding to different salesmen is, this was the table given in horizontal form. So if we go by only this particular stage 1, so here we can see that the maximum value for each of the salesmen and their corresponding profit values will be like this, and we can see variation of this, and we can see only maximum value is for number of salesmen 7 with value 105,000. This is the return. This is the return. This is what is the return of stage 1. The return of stage 1. Now we know that in the last slide we have seen zone 1, zone 2 and zone 3 with 0, 1 up to 9, and these are the values. So only considering zone 1, this is outcome. Now I can use either 0 to 9 as a combination. This is only applicable if I am considering single stage, that is only covering zone 1. I am repeating, only covering zone 1. But if I consider now, this is very important, if I now consider that I will go for zone 1 and zone 2, I will have a combination of these 9 salesmen in the form maybe 1 plus 8, maybe 2 plus 7, maybe 0 plus 9. This is just for example I am giving. So here you can see that whatever combination I am giving, it is satisfying the condition that total number of salesmen are less than equal to 9. So in that way we have to proceed. That is very important. Got it? For stage 1 this was not required. Now for stage 2, since I am using 2 territories and I am having 9 salesmen, I can divide those 9 salesmen in zone 1 and zone 2 accordingly as per given combination in this particular example. And addition of values of profit, and addition of values of profit for that will be the total output from stage 2. How it works, that we will see. See, now this is the stage 1. Now this is very important, this is stage 2. As said in previous slide, this stage 2 will be for zone 1 and zone 2, which will be giving you f1 x1 plus f2 x2, that is written from first and second, and then we will see which combination is giving optimal. So what is done, understand this, we wrote all values of zone 1. These are the number of salesmen, and this is profit in 1000. Similarly, this is salesman and this is profit. So this profit is referred as f1 x1 for x1 and f2 x2 for stage 2. And what we are interested is in finding addition of this. Now students, very important, here you get combination and you have to focus on that. See how much. Suppose this is the tabular way to solve such problem. Now I can have the combination of first appointing no salesman, that whatever the reputation of company, without any salesman the product will be sold and the company or firm will earn profit. So no salesman, 0 salesman, zone 1, 0 salesman, we get this value. This is, I am highlighting 65. How this 65 is obtained? For 65 is sum of this 30 and for 0 35. So 30 plus 35 without any salesman, f1 x1 plus f2 x2 will be 65. Very important, very important. Now suppose this is the first case where I have decided, okay, we will go for no salesman. But if we decide no, deputy salesman, I can have a combination that no one salesman for zone 1, one salesman for zone 1, I can have, I will tell that one salesman for zone 1 and no salesman for zone 2. Very important, very important. So total number of salesmen are 1. One may think I will depute one salesman for zone 2. I will depute one salesman for zone 2, getting, and 0 salesman for Z1. Again the sum is 1. Now what you have to understand, see, this is differentiation wall I am putting in between. The combination is like this. For one salesman, I have two options. For deputing one salesman, I have two options. First option is one salesman to Z1, no salesman to Z2, vice versa. Other option is one salesman to Z2 and 0 to Z1. Both combination gives me only one salesman. So I will get two answers of F1 x1 plus F2 x2. See, if I take this combination, first combination, this one, so I will be getting here the value for this suppose I am writing now. This is how I get this value 45 by deputing one salesman, and for this if I depute 0 salesman I get 35,000. So what is the total? 45 plus 35 is 80,000. 80,000 is by this combination. 80,000 is by this combination. Now for this combination, let's see what the value is. Suppose this is the combination, I get this value. So this value is obtained by deputing one salesman with 45. So here this is 45 by allocating one salesman to zone 2, and if I allocate 0 salesman, it gives return of 30,000. So total is 75. So ultimately what I get here? 75,000. This is very important to understand. So students, see, for these two combination you are getting two values. These are the sales values, 80,000 and 75,000. These are the sales value for deputing one salesman. And what is our objective function? Objective function is to maximize sales. So which is higher value of sales from 75,000 and 80,000? Definitely 80,000 is the highest value. So now what is important? Very important. What is that? See, you are getting these two values. But these values are across diagonal. Rather, what I will do, these two values are across diagonal, means these two values. And I am interested in a larger value, that is 80,000. So what I will be doing is, I will be putting for reference star mark amongst, this is very important, star mark amongst largest diagonal value. For this first case, there is no diagonal, there is only one value. So no option other than to mark this as star mark, because there are no two values, only single value. Now let's again see with one example. Suppose I have decided to depute two salesmen. So option will be either 0 or 1 or 2 in combination. I want total 2. I want total 2 in each zone. So it can be sum of 1 plus 1, 1 plus 2 or 2 plus 1 in zone 1, zone 2. In zone 1, zone 2. See here, for the combination of these two salesmen, suppose I take these two. If I take these two, I have to take 0 from zone 2. So 0 plus 2 is 2. I have to add this value. 60 plus 35, it will be 95. So one value is 95. If I take, instead of 2, we'll go for 1-1 combination. This is not, this is 1 plus 1. This is not the case. Maximum we want 2. So 2 plus 0 is maximum, either 0 plus 2 plus 0, 0 plus 2 and 1 plus 1. These are three possible combinations. These are three possible combinations for 2. Either 2, other 0, 0, 2 or 1, 1. Suppose we take 1, 1. 1 from zone 1, 1 from zone 2, 1 plus 1, 2 and profit is 45 plus 45, 90. So here I get 90 value. And suppose I go for 2 from zone 2 and nothing from zone 1, I get 52 plus 30, 82. Students, again important, you get these three diagonal values. You get these three diagonal values. Now this will be repeated. This will be repeated. For three diagonal values, your answer was 82, 90 and 95. Obviously, 95 is maximum. So what we'll do? We'll star mark 95. Suppose further I have combination of, I want to go for 3 salesmen. So it will be Z1 3, Z2 0, then Z1 2, Z2 1. Got it? Total should be 3 and vice versa. So how much value you will get? In that 4 values. So likewise we get one more diagonal values for the combination of 3. Select maximum. See here, you may come across this. That is the reason why I have taken this particular problem. You may get maximum sales value at 2 places. So we also got the same situation in earlier problems where we have solved that problem by tabular method. So we have made star mark to those values also in that particular table, if you recall our earlier lectures. So here I am getting 2 values. So I have marked star these 2 largest value. Now likewise we calculate for all combination, and the values for 9 combinations are obtained like this, and the last value is, which you can see is diagonal, like this. Now this value of 125 is as a combination of 9 and 0. This 145 was 8 with 1. This is 7 with 2. This is 6 plus 3. This is 5 plus 4. This is 4 plus 5. I am talking of zone 1 and zone 2 combination. This is 3 plus 6. This is 2 plus 7. This is 1 plus 8, and last is 0 plus 9. So we are ready with all these values, and students, amongst these values you can see this 163 is the largest for combination of for total 9 salesmen, for 9 salesmen. Now what is important? How this is the second stage. Earlier we saw first stage, F1 X1, direct return from deputing 0 to 9 salesmen in territory 1, that is zone 1. Now what we did, moving in a dynamic way, we have differentiated salesmen for zone 1 and zone 2 in such a way that we get the total combination for both zone 1 and zone 2 in such a way that it satisfies total salesman constraint. Now what we'll do, we'll be taking these star mark values, maximum star mark values for next stage. Whatever combination we get for F1 X1 plus F2 X2, whatever combination we get for F1 X1 plus F2 X2, maximum value, we will be taking that values and we will be considering those values with third zone, that is F3 X3, and we are having the output of F3 X3. So we will be repeating the similar table in next iteration, only the difference will be one column will be purely of zone 3 with output F3 X3, and one will be for row wise, will be for either row or column wise, will be for combined of zone 1 and zone 2. Then we will have combination of salesman combined zone 1 and 2 with zone 3. I think now you are getting it. In next table, what we will be finding? The optimum output to be obtained by combination of total 9 salesmen in such a way that optimum of zone 1, zone 2 with number of salesmen for zone 3. How that we'll see now. See here, this was our second column. Now you remember this value 183, for example, not 183, 163, and 163, this 163 is maximum for a combination of 9. Like for every combination we have star mark values. So what is done in next table is, see here, very important, this is total profit which you get by addition of zone 1 and zone 2. These values, all these values are maximum sales value of Z1 and Z2, and these values represents combinations of salesmen of Z1, Z2, Z1, Z2 like that. So from previous table we know that how we have identified whether he is from Z1 or Z2. So this is the solution obtained from zone 1 and zone 2. Now we will check its possibility with zone 3. And what is the zone 3 total profit? It is optimum of your profit of optimum profit from Z1 and Z2 zone with current decision. See here the number of salesmen were written from 0 to 9, and here for zone 3 we have written salesmen from 9 to 0. So see, in simple words, we will have this combination of this 0 with 9. This will lead total 9. If I make combination of this 1 with 8, again total salesman will be 9. Like that, for any combination in this particular rows, if you add these vertical values, it will lead to the combination that total is 9. But remember, if you consider for zone 3 number of salesmen as 0, then you have for zone 1 and 2 total 9 salesmen. Yes, you have total 9 salesmen, and you have already calculated division of these 9 salesmen amongst zone 1 and zone 2 as 6 in zone 1 and 3 in zone 2 in previous table. Got it? Now, as we did addition of this number of salesmen, what we have to do? We have to add the profit also. Suppose I get this 175. How this 175 is obtained? This is 65 from this is 65 from this value, and for 9 it is 110. So total of 65 plus 110 is 175. Students, like this we have calculated, added all these respective values of sales, and we got this last decision making row. This is very important. This is last decision making row, we got it. If we look values of profit amongst the row of total profit, we get 210 as maximum value. We get 210 as maximum value. So what I did is, I have star mark 210. Now it is 210 in thousands of rupees. So the sales is, total sales is 2,10,000 rupees. 2,10,000 rupees. Got it? Now we have to find the division for this. For this we have to find Z1, Z2 and Z3, how many salesmen. So for this 210, this is output of this 115 plus 95, and for 95 your number of salesmen are equal to 5. So 5 is fixed now. Then from zone 1 and 2 you are having total 4. Total 4. You are having total 4. So now your task is over. One task is over, that 5 plus 4 is 9. But how these 4s are divided amongst zone Z1 and Z2? That you can get it from the value which we have star marked in previous matrix as 115. So let's go back. Remember this value of 5, and now we will be seeing division of 4. So, and for 4 it is 115. So let's move backward. 115 for 4. For 4, this is your value. For 4, this was see, the diagonal for 4 looks like this. And we have star mark this value as 115, and this 115 is the combination of 3 salesmen from zone 1 and 1 salesman from zone 2. In that way it gives you 4, and right now we have estimated 5 from zone 3. So the division will be 3, 1 and 5. Our answer will be 315. So you can see here 5 salesmen in zone 3. From remaining 4, 1 is in zone 2 and 3 zone 1. So as I have written in previous slide, so zone 1 3 salesmen, zone 2 1 salesman, zone 3 5 salesmen. Total is 5 plus 6 3 9, and this particular is our sales figure. So this is how other way we are solved the problem with discrete variable. So now let's move ahead. Now here this is very important problem again. Determine the value of u1, u2, u3. We have to find the value of u1, u2, u3. Objective function is given. Objective function is given as u1 plus u2 plus u3, whatever value of u1, u2, u3 we calculate, if we multiply we will get maximized value, that we have to find. Means indirectly we have to find the value of u1, u2, u3. Now the constants are given. This is very important. The constants are given. The sum of these u1, u2, u3, it is equal to 10. It is equal to. It is not given less than. It is not given in the form of greater than. It is only given whatever values we obtained must satisfy this condition that u1, u2, u3 is equal to 10. Got it? This is very important. Now and see here, u1, u2, u3 is given greater than equal to 0, but it is not mentioned. It is not mentioned that it is integer. It is not mentioned here. It is integer. Would it have been mentioned? This is a very important statement I am making. If this problem has mentioned that u1, u2, u3 greater than equal to 0 and integers, then we can solve this problem by previous method of tabular form. When it is integers means continuous values are not accepted, and we have seen that in tabular form we are not getting continuous values. So here, since integer is not mentioned, we have no option other than to go for calculus method. We have to go by calculus method. Steps are same, that you have to find state variable, you have to find objective function of final optimized function of each stage. So here this u1, u2, u3, again, since 3 terms, 3 stages. Problem will be in 3 stages. So it will be defined like this. x3 stage, it is sum of u1, u2, u3, maximum value 10. Stage 3, final stage. If I go for x2, I have to subtract this u3 from x3. So x2 is, if you recall, in our last lectures, series of lectures, we have many a times written this particular state transformation of x2 will be equal to t of x3 y3. This equation we have studied. So likewise we find first, second, third variable for different stages. So x3 is obtained by subtracting x2 is obtained by subtracting u3 from x3, and ultimately what you get? u1 plus u2. Similarly, x1 is obtained by subtracting x2 from u2, like that, and you get this x1. Now very important, these are the values of optimization for each stage. Now this is f3, x3 is for stage 3, this is for stage 2, and this is for stage 1. Now one thing you have to remember, what our intention is maximize, and therefore it is written maximize. We have to solve it for maximization. Now here you can see multiplication of 2 terms. So this is current decision for f3, x3, u3 is last stage variable, that is current decision of current value of u3 with optimized value of previous stage. Previous stage is f2, x2. So f2x2 is maximum of current stage is u2 for f2x2, previous is f1 x1, and f1 x1 is first stage where value of x1 is u1, and u1 is obtained as a result of x2 minus u2. So this is very important. So ultimately you immediately get this relation of f1 x1 without doing anything. Now f2 x2 is equal to maximum of u2. See here that relation, maximum of u2 plus f1 x1. Ultimately what is f1 x1? It is x2 minus u2. Therefore this f1 x1 is replaced by x2 minus u2, and this is then solved as we have multiplied this u2 by x2, so u2 into x2 and minus u2 into u2 into u2 is u2 square. So ultimately what we get for this f2 x2, we get this relation. Now students, very important, for finding the value of u2 we have to use calculus method. So what we do in that, we'll differentiate this particular equation f2 x2 with respect to u2, and we'll find the and equate it to 0 and find the value of u2. So now it will be simple differentiation of this with respect to u2. This is first term and this is second term minus. So we have to differentiate this u2 with u2 x2 with respect to u2 and minus twice u2 square by u2 square with respect to u2. So simple rule of differentiation that will apply, and we'll get the value of u2. So that step I have written here. So if we differentiate with respect to u2, so that will give us answer of like this. So x2 minus twice u2. So how come? This is differentiation of u2 with respect to u2 is 1 x2. So this will be x2 minus it is u2 square. So differentiation of this u2 square with respect to u2 is twice u2. So ultimately what we get is, when I differentiated this with respect to u2, f2 x2 is equal to x2 minus twice u2, and you have to equate to that 0. So ultimately our answer is this. Equating 0, and if you take to right side, you get the value of u2 as x2 by 2. This is very important. Now Bellman's principle of optimality is also to be applied in calculus method. So for finding f3 of x3, so you are now with value of u2, and this is the value of u2, so that you will put for f2 x2. So f3 x3 will be equal to maximum of current decision of u3 into value of u2. f2 x2 is x2 by 2. So if we square it, it will be x2 square by 4. So now your final relation becomes f3 x3 is equal to this one. Now here you are having two terms. f3 x3 is equal to maximum of first function. This is your first function. This is your first function, and this is your second function. So again, to find the value of u3, what you have to do? We have to differentiate this particular with respect to u3 first function and second function, but there is product multiplication side. We know the rule of differentiation. When we have multiplication side, what we do? First function into derivative of second plus second function into derivative of first. By doing that logic, we get the value of u3 as 10 by 3. We get value of u2 as 10 by 3. Going back in a reverse direction, we have u2 value is x2 by 2. x2 is the terms of x3 and you get u2 is equal to 10 by 3. Again going back, you get u1 is equal to 10 by 3. So ultimately the values of u1 and u2 is 10 by 3. Each value is 10 by 3 and the maximum value which we are supposed to solve by that method is u1 into u2 into u3. So value is 10 by 3 common. So 10 by 3 cube is 1000 by 27. So like by differentiation method, by using the principle of calculus, we can also find the values for continuous variable. I think now same problem can be here. We have stated that u1 into u2 into u3 as maximum z. We can have another problem as maximum z is equal to u1 square plus u2 square plus u3 square. Find the value of u1 and u2. So in this way, discrete variable problem and continuous variable problem are solved by the concept of dynamic programming. Remember, if it is discrete variable problem, when you are finding solution, use method of tabular calculation. Whenever it is the method of finding solution to continuous variable problem, use calculus method. So students, here we are ending with the topic unit number 3, that is dynamic programming. From next lecture we'll start unit number 4, and that is project management, which is very important topic of operations research technique, and it has a wide application, large application, very large application in day-to-day life. So here I am ending this today's lecture. Practice similar problem so that you get confidence in dynamic programming.